Hi, Kaustubh. How are you today? How was your day?
I'm good. I'm good. Thanks for having me here, Nayanika. It's been a long day. I just got back from the office. Fought some guys on the Bombay roads. It's just like a lot of traffic, but I'm glad I could make it. It's been a busy week. I'm looking forward to the weekend.
Hi, we all are looking forward to the weekend. Could you tell us a little about yourself and what you're doing right now?
Certainly. So my name is Kaustubh, which you'd probably be able to tell from the YouTube link. I'm trained as an electrical engineer. I specialize in nanofabrication and technology, MEMS, thin film technology. It developed as a sister technology to the semiconductor industry, and a lot was taken from IC manufacturing to MEMS and microsystems. So my specialization lies there, where I'm able to use certain manufacturing techniques from semiconductor manufacturing to make not just electrical products, but mechanical products as well. So I did my undergrad out of from Mumbai, and then I went on to do my master's with the intention of doing a PhD in MEMS. So I enrolled as a master's student at Carnegie Mellon in Pittsburgh, and I started working under a professor, Professor Gian Piazza, on RF MEMS. And that really, like, my university didn't have a clean room, but when I went to Carnegie Mellon, there was a massive clean room there, and something that matches that you see in the industry, right? It wasn't just a basic academic clean room. And I, right after my orientation, that's where I wanted to work. I knew I wanted to work there. I enjoy working in the lab. So being with Professor Piazza allowed me to be in the lab. And then once I was in there, I started from scratch, just doing very basic things. I was in that as a student, you're supposed to pay your dues, right? So
Yeah,
just did like
definitely.
basic things. And once you start working in the clean room, because it's a shared lab, it's a shared facility, you get to meet a lot of people and get to learn about a lot of research. And just like that, I met a new professor who had just started his appointment at Carnegie. His name was Professor Chamanza, Mason Chamanza. He had just moved from UC Berkeley, and his work was on developing neural probes, flexible neural probes. So just to get more experience working with organic polymers and not just silicon, I decided to work with him, and more like he allowed me to work with him, and that's just the way how I got into this field. It was I'd say it's just a coincidence. For me, I wanted to be in the clean room, and being on Mason's project allowed me to work in the clean room and learn something new. I didn't have a background in biology or neuroscience, but I just started picking up research, right? Because MEMS is a technology that you study at the graduate level, and not at the undergraduate level. So really, you don't stick to textbooks, or you don't stick to videos. You have to read papers, you have to read journals. And slowly I got into that, and I started working with flexible polymers and performing, doing microfabrication on them. So I was able to we published some work that we did out of Mason's lab, and after that I started interviewing. My intention was to do a stay, but I also wanted to get some industry experience. And just by happenstance, I got connected to Neuronexus, and I interviewed there, and I got in. So I spent 2 months as an intern with them. I learned their craft. I learned how because working in academia is different, right, from working in industry. And so I just, as an intern, I picked up on these basic things, and then they had me train in the clean room in Mission. This is a bigger clean room doing industrial processes. And finally, I got an offer from them. At that point, it was a difficult decision for me. At that point, I was wondering whether I should do PhD or continue with industry. But I thought, let's get some experience under the belt, and went ahead. And my time at Neuronexus was amazing. So post that, Neuralink happened, and then back in India running Eywa Neuro. So quite, it's been the past few years have been pretty awesome.
Awesome, awesome. That was like listening to you made my day. That was so exciting. It's like
Thank you.
awesome. So So you said that you joined Neuronexus and you joined
Yes.
there as a micro fabrication engineer. So like and you said that it was different than the academia. So what was your daily work at Neuronexus like?
It was fun. It was chaos. It was a small company, right? So, and all small companies, the rule 101 is all hands on deck. Like if you can do something and if you can help out, that's what you do. So since I started off at a junior level, right? And I worked there for a few years and climbed my way up. It for me, and I spent most of my time in the clean room. The ideas, we used to have weekly meetings where we would talk about R&D projects, we would talk about collaborations with other institutes or other companies. And my role was essentially being in the clean room and translating our thoughts into potential prototypes. Alongside that, I also did a production work. So things like running, doing design of experiments, keeping track of, how your production goes, uh, just, all of the ISO requirements, right, that you need. So started doing the documentation work, started doing production. But as I progressed in the company, I think I like to be more involved in R&D. And then for me, like I got a lot of mentors there. So I used to work under my mentors, Jamie Hetke, Dr. Pelleman, and we started, whenever there was a new project or whenever there's something, this new R&D happening, I was involved in them, and I started getting my own ideas. So I essentially got trained at Neuronexus to get to that stage where I could, now start formulating my own ideas and then translating them. Because it's one thing getting ideas, right, publishing in academia, but it's another thing trying to scale a product. Like you can't just say,
Yes.
I can make one of these. You have to be you should be able to make 1,000 of these. And that's where the difference lied between working in academia and working in industry. It wasn't just about publishing your papers, it's actually about, get things into action. So my usual day would just be, in the clean room. I would spend at least 6 hours a day in the clean room, and then the other few hours it was more about research, more about, learning about new technologies, getting customers, and just trying out things. I would say meetings, basically. Primarily though in the clean room. I think I spent more time with the machines in the lab than I did with my colleagues.
Right. Okay. So like clearly you were having an amazing experience at Neuronexus. So like what was the reason behind shifting from Neuronexus to Neuralink, which is,
Um,
yeah.
I think the business models for both the companies were different. For Neuronexus, it was more catered to the acute market. So it was more about building. It was a platform technology. It was able to. Neuronexus was a company which researchers would go to, industries would go to, and get their devices made. I while I love that, and there's so much I got to learn through it. The one goal that I had, at least like it was a desire of mine, that I never got to work on a medical device, an actual medical device that would get translated into humans. So far, my work at Neuronexus was all about, electrophysiology, animal experiments, but never an FDA approved product. So when I learned about Neuralink and Dr. Tolosa, Vanessa Tolosa was one of the co-founders, we spoke, and it really, I think it presented, being working at Neuralink presented me with an opportunity to not just continue doing my technology, but also building something that can truly impact human lives. And again, I probably won't mince words, but having, an Elon Musk company, right? You're attracting the best of talent. Even when I was there, like, so many people across the world, right? Not just the US and not just California, across the world were applying for this job, and working with, potentially working with some of the best engineers and neuroscientists there. I was attracted to that, and I thought, and as much I'm still in touch with my family at Neuronexus, but I thought this was a good career opportunity and something that would not just allow me to continue my work in research, but also allow me to understand how you design a medical device and how you get it approved. So both the skills, right, were that I sought were, complementary, and the reasons why I went to Neuralink.
Right. So the last
Another
time,
smaller,
okay, yeah,
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 sorry,
go ahead,
another
go ahead.
smaller reason was the weather. Maybe the weather in Michigan is really cold, and we're beyond the point you do miss sunny weather, especially like when you're from India, right? Like
Yeah,
you miss.
definitely, yes. So last time we were talking, you were discussing and sharing your experiences about working with on the Monkey Mind Pong project, and
Yeah,
it definitely broke the internet. Like, and I'm sure
yeah,
everyone wants to hear the behind
yeah.
scenes of it. Like, could you share how your experience was and what were you
Yeah,
working on in it?
yeah, certainly. I think I won't to get into too much detail because of
Yeah,
company
definitely.
confidentiality clauses, but uh, I think we knew we had a good product on our hands, and we there was a point where all our prototypes were working. We've got good data, and just it was never done before, right? Like no one's ever done that before. Just being developing a robot and developing these really tiny electrodes that could be implanted. And I'm not talking about one implantation. You're having an actual array with the robot sewing threads into your brain, and those continuing to last, the implant and the explant without causing any damage to the patient. That was phenomenal, and we knew we had something cool on our hands, and we had to get there. It was the company's and Elon's vision to see cybernetics becoming a reality. And I think the straightforward way initially, for us, it was about helping people to this technology, it's needed by those people. Would make their lives really easy. To get to that stage, we traditionally you have to go through different animal models, and you have to conduct something called as GLP studies, good lab practices studies. So with the creative genius that was there at Neuralink, we didn't want to keep it boring or mundane. We thought let's try something. We've got the resources. Let's try something fun. So the Gertie pig video, right? Like the music video, whenever
Yes,
we
yes.
thought you could drink music, and then the Monkey Mind Pong, just like being able to for a monkey to play, pong with his brain, phenomenal. Like it was an actual game, and the monkey won. So phenomenal. I think behind the scenes we were all very excited. We had confidence going into the project, which is why we did a live demonstration. As we wouldn't have done a live demonstration if we weren't confident. And it fortunately it went well, and everyone was happy. I think there's a party after. And just good times. I would say. There's still a long way to go, but you got to celebrate like each success, right? Each
Yes,
node of success.
that was a
So
milestone. Yeah, definitely.
it was not just for the company, but for the industry itself, and for the community. So just happy days, I would say.
Yep. So, like, clearly you were having the time of your life at Neuralink. So, what made you realize that it was time to leave Neuralink and have your
Yeah.
own startup, Eywa?
Yeah. Mhm.
So,
That's a good question, and sometimes I keep asking myself that every day. It's I think there's a lot of reasons. Personal reasons were probably the highest priority. I think being a single child, my parents were still here, and times of the pandemic had hit, and things were becoming challenging. So, just for personal reasons, that was the primary cause. But at the same time, I thought having spent so many years, more than half a decade in the US, I figured I had I had all the tools needed for me to try and do something of my own. Uh, for again, like touch wood, like those are scary times, to be honest. It's difficult leaving a cushion job and exciting job. Like seldom do you get a job where you get to do what you want to do and you get
right.
paid for it. But again, like responsibilities and just the desire to, I think, do something of my own. Again, like without divulging too much about Neuralink, each company goes through a cycle, right? Where there's R&D, there's an R&D phase, there's a production phase. So for me, I think I missed the R&D phase a lot, and I had some ideas of my own, which was separate from what I did at Neuralink or what I did at Neuronexus, and I wanted to pursue those. I saw that as a marketable opportunity, and just the economics of it worked out. So being in India, able to do the same thing, and then we had applied for a few. I found we were able to apply for a few grants, uh, just get enough money to start up.
Mhm.
And fortunately, like by God's grace, we were successful at that. So it's our first run, which we thought was just trial. We were able to sell those devices,
Mhm.
and not just sell domestically, but even export those devices to the US. And that gave me more confidence to do this. So just a lot of reasons, and I would say like each day my confidence in this decision grew, and there came a point where I eventually committed to it, and that's how it happened.
Yeah. So like, let's go a little back in time, and like, could you give us your elevator pitch for Eywa? So, what is the idea
Yeah.
behind Eywa?
Sure. Yeah. So Eywa Neuro is again. I want to start with what Eywa means. If you watch the movie Avatar, Eywa is the tree of enlightenment there,
Yes.
and what we do at Eywa Neuro is we're building a platform technology that's not just for invasive neural electrodes, but electrodes, any sort of bioelectrodes, and we want to build this platform technology with proprietary science and material science. So what we've done is we've got our own stack of thin film materials, and we've developed our own polymers. And that allows us to do is really tune those to what we need instead of buying something from off the shelf and then working with it as best as you can. So the fact that we have our own materials and
Mm-hmm.
the ability uh, to tune our film stack, that really leads to now a more promising future, because every neuroscience is not there's no one solution fits
Mm-hmm.
all for that, and then customization is really the key. And having our own technology, our own polymers, our own technology, our own designs, that allowed us to now just build something that works really well for a particular application. And this is the platform technology that we want to advocate. We want like, researchers, right from electrophysiologists to doctors to neurosurgeons, come try us, give our a try, and they've been tried and tested. So it's there's a lot of confidence in the product. The eventual goal again is to get a medical device out of this, but Eywa Neuro is all about connecting neurons, and we have the technology to do that.
Mm-hmm.
So, and it's India's first ever company, first ever lab, in fact, to make such labs. So take immense pride in it, and that's how I want to go. At the end of the day, I think there are a lot of people in India who need this technology. That gives a lot of creative fulfillment from our work. And monetary success aside, that's really the eventual goal. Because there's one thing, being one thing making implants, right? And that's
Mm-hmm.
cool. You get bored of it after a while, but there's another thing, knowing that your implant, the one that you've made, is in someone's brain and is helping, improve someone's life. Uh, so that's what it is. That's what Eywa is. That's what Eywa Neuro is. So, right? Like there's so much potential in India,
Mm-hmm.
and it's not just that. I feel there's an ecosystem now building up in India, and because competitive nature of science in India, I think it just pushes us to do better. Now that
Mm-hmm.
complacency that I had maybe a few years ago, that hey, no one's gonna do this, no one's gonna know how to do this, is slowly fading away. I see a lot of cool startups coming up, and they're doing excellent science. They're doing things that would help people. So it just makes me like pull up my boots and just work harder. So a lot of things, right? Like a lot of things that India is great for. Just made me want to come back.
India has been for the past few years a land of unicorns. But
Yes.
so, like, do you think that the government has initiatives and favorable policies for biotech and healthcare startups these days, or are they coming up with such policies?
I think they are. I think especially after COVID, they realized that without having an indigenous healthcare system or an indigenous supply chain of
Mm-hmm.
medical devices, it's difficult for us to keep up with the demand that's there in the
Mm-hmm.
country. You look at China; they're not just doing well domestically; they're even exporting, right? They're the
Mm-hmm.
global exporters. So India has that potential. Uh, and the government's doing a lot of work for it. They've given out a lot of incentives. They've subsidized a lot of shared resources, shared labs. They've definitely, again, it's the same problem with economics, right? Like the resources are limited and demands
Mm-hmm.
are unlimited, infinite.
Mm-hmm.
But from what I've seen and what I've experienced, I think they're doing an awesome job. There's so much. They've made it lucrative for people to come in and do this. And that mentality that was there maybe 15 years ago, 20 years ago, where people shirked away from quitting their job to start a company, that's gone now. People have the confidence to get in. They know they're going to get the right help, and they know you know success or failure comes later, right? But the first 3 years, I would say, is critical, and
Mm-hmm.
parents there with you. They do help. As far as unicorns go, I don't know. I think I think that's a healthy debate, right? Again, I could be wrong, but I like to believe in revenue more than
Mm-hmm.
valuations, because sometimes they
Mm-hmm.
don't go hand
Right.
in hand.
Yes.
Like without naming a lot of unicorns,
Mm-hmm.
the revenue is probably
Yes.
not reflective of what valuation they have.
Mm-hmm.
But
Right.
having said that, for me, I personally do not like diluting my company. I like to have creative control over it.
Mm-hmm.
And so far, I'm okay not drawing a salary, but I still want to sell, right? I want my products to
Mm-hmm.
go out. I want people to trust them, and I want the revenue built up. Uh, Raising money, everything else is later. Like, as long so far we've been lucky that the our sales have justified our production costs,
Mm-hmm.
and like including our salaries. And I want to keep that way. I'm sure we'll reach a point one day where we would need more investment to meet up with the demand. But until that point happens, I think I'd like to run the company by myself. Uh, but I know, for your question, like, with where can this become a unicorn? Does India, or does a biotech startup in India have the potential to be a unicorn? Absolutely. I mean, you look at Dr. Shaw, right? Who's made the COVID vaccine, and
Mm-hmm.
that's an example right there. She didn't. It took her years. It took her more decades, in fact, to get her business up and running. But it's there. It's definitely there. And often people don't realize this, but a lot of medical devices, such as syringes, hypodermic needles, bedpans, India exports those into vaccines now, right? India exports those, so there is definitely potential to be a unicorn. The idea that we have has potential to be a unicorn. It's just like how we get there. I think the path is yet to be traversed.
Right. Yes. So I meet, entrepreneurs like you, and I'm always in awe. But I personally am very scared of the entire process of setting up a startup, even if I have an idea. And so, like, could you please demystify this process a little and share your journey from converting this into from an idea to a startup?
Yeah.
Like, how do you get it
Yeah.
registered? What do you have to do, and what do you do after that?
Yeah. That's a good question. I wish I had that guidance before I started off. I think the key, and this is what, from this is just my experience. Again, I could be wrong, but for me, the key is to get all the regulations in place. Before you start, you're not going to start a company unless you have faith in your technology. But
Mm-hmm.
before you start, get all the licenses, get all the admin stuff out of place. Things like, how do you do your accounts? How do you do your sales? Who's going to manage, who's doing, how do you do exports, how do you do imports, all of those things, we take for granted. It's different for an individual to purchase something from offshore, but for a company, you have to justify it. You got to do accounting, and that's
Mm-hmm.
where a lot of startups fail, because they don't plan for the accounting. They go ahead in thinking that it's okay, we'll recover it later, we'll get investment later. But I feel the key is to plan and just to do your research. uh, Once you have that, you've got the right approvals in place. Once you were able to be free of all admin hassles and just focus on your technology, I feel like that's when you dive in. Because and a lot of people have said, this is not my original quote, but for any person, time is a commodity, right? Time
Mm-hmm.
is the most valuable asset as an owner, because there's a concept in economics called marginal opportunity cost, which means like, what are you losing out if you did something else for the same time? How much are you losing out as compared to what you're doing today? And you have to keep that in mind, and you have to remind yourself that every day, because time just goes by quickly, right? Like you're a year in, you're 2 years in. You have to push, and you have to keep that opportunity cost. There's like, let's say you're earning 100 rupees a year. If you're not earning anything for 2 years with your startup, you're missing out on 200 rupees, right? Again, this is an exaggerated example, but
Mm-hmm.
that 200 rupees is the value of your time. And you have to ensure that you plan your startup, you plan your journey such that you got to hit more than 200 rupees before those 2 years in, because that's when you're successful. That's when
Mm-hmm.
you're really doing your job. So my advice would be, get all the admin duties in place. Things like GST registration, getting a bank account set up, getting a,
Mm-hmm.
exporter's license, your AD code registration. Get all that set up, because otherwise you're going to run into hassles and you don't know what to do. Once you have that right framework, then you're ready. Like, and you stick to that framework, then you're ready. Another thing, like, probably I'm advocating this, but probably not necessary for a lot of people, but try and get ISO approvals, because
Mm-hmm.
the guidelines that they offer, they're tried and tested, which is why people stick to them, right?
Mm-hmm.
And when you're able to manage the quality of your products, when you're able to manage the resources in your company, that's when your utility goes up. So we did that, like, even the first production run. We started putting systems and practices in check, and we started pushing that. I feel that helped a lot. I did make a
Right.
few mistakes
Mm-hmm.
initially, but we've come to that stage where I'm comfortable now to go to a customer, show them my product history, and then just sell. So for any new entrepreneur, I would say, get the first word of advice is get all the documents in check. Yeah, you could learn that in an MBA. You could learn that from a course, but when you're actually in the thick of things, there's no better teacher, right? There's no better teacher
Right.
than experience.
Mm-hmm.
The second thing I would tell people, like, for a who want to commercialize idea, is do your due diligence, because an idea can be cool, but can it sell? And that's where success lies.
Mm-hmm.
So never evaluate an idea by how well it works. Always evaluate an idea on how well you're able to sell it. Because if you could make a time machine, and if no one
Mm-hmm.
buys it, your company is going to go run
Right.
out of business.
Mm-hmm.
But so do that due diligence, do the pricing, do the costing. Make sure you hit the right briefs when it comes to competitive factors, when you're as compared to other sellers in this space. And the thing I would say is ensure you use your time. Uh, don't wait. I would say, like, if there's something you want to do it today,
Mm-hmm.
because I think there's is a popular. I don't know. A lot of people stick to it. Some people don't. But there's a funda called fail first or fail fast.
Yeah. Mm-hmm.
So when you're able to fail clean, that's when you know where to pivot, and that's like that failure is more guiding you more towards success than continuing to perfect a product.
Now that Eva is growing so and doing so well, I think everyone would like to know if you guys are open for hiring, and if
Yeah,
yes, then
absolutely.
what skill sets are you looking for?
Absolutely. I think so far we're still small, but we're hiring technicians, and we're hiring interns and folks who are primarily who I think, like, again, this is just from my experience. We're not looking for skills. Today, especially in like this era, Industry 4.0, diversity and being able to be more flexible with your skills is more crucial than having just a niche set of skills. So anyone who's enthusiastic and who's like a hustler, maybe that's probably the right word. But anyone who can do that, I think we're totally on board for getting them with us. And we want like-minded individuals, right? Like those who will continue to persevere instead of just looking at this as a job opportunity or as salaries. But we're open to hiring. I think I also want to encourage get more interns here because unfortunately, I don't think that these courses are often a lot of universities, especially at the graduate level or postgraduate level. So I want to be able to get interns in, show them this, and then train them. The clean room is a great place. Like it's Candyland. As long as you're wearing a protective gear, it's Candyland. So it's difficult for young students to get experience there. I'd be happy to. I want to train more people in the clean room and then just build up a workforce one day.
Yes, yeah, even I agree. Like most of my learning has been via interning at startups. The hustle culture at startups is the best way to learn anything. You are under pressure, you are under strict deadlines, and you obviously have lesser resources than a large tech company would have, and it is an absolute thrill. It is definitely. I think it's good that people are encouraging students and enthusiasts to apply for interns, even if they don't have the skills. And people are often very scared about it. Even I was for quite a lot of time. Another thing that I'm really worried about is when I talk to people in the neurotech industry, they often say that a PhD is very important for making it into this industry. And so, like, what is your opinion about it? Since you obviously made it big with a MS degree, so I would love to
Thank
know
you.
your take.
I think it depends on personal preference because it's a PhD traditionally. It's probably like a little long answer, but a PhD was essentially a road to get into academia and to get into pure research, right? It was never about scaling something or production or being able to sell a device. So that creative aspect of a PhD was very lucrative and it drew a lot of people in. This field, you're right. In neurotech, at least I would say for people who graduated up until 2010, maybe, they needed, this kind of research because for them it was difficult to acquire such skills, right? And these skills also are acquired at a graduate level. You don't get that at just the undergraduate level. So a PhD would help that. A PhD would get someone in and then train them, put them through 5 or 6 years of rigorous work, a few years of coursework, and then a few years of research. And at the end of the day, you're a doctorate, right? And you're trained highly specialized in one thing. Like what is a PhD, right? At the end of the day, a PhD is nothing but you come in as a student, you work hard, and then you publish a thesis, or you publish a few papers, and then which eventually culminates into a thesis. That one thesis is how do you evaluate that, right? How do you it's the cost of that thesis that is where the key is. So let's say you do a PhD in machine learning, right? You know that it's a new field and it's growing and there's a lot of investment in it. So someone like Microsoft or Amazon, they're easily going to pick that thesis up. They're going to say, oh, Dr. Nayanika did this, and they're going to hire you, and you're going to get a good paycheck, and your research gets translated. On the contrary, you also see a lot of PhDs who work on cool things, but which never get translated, right? That's a problem because you need to know that if that happens to you, I'm sure you've learned a lot about that one particular thing, but if it's not commercial, then you're at the end of 5 years or 6 years, you're beginning as a student again. It's back to square one.
Right.
You've lost out on those 6 years of your time. My personal journey was different. So I was able to get a job at a neurotech company. So my 5 years of experience there, both working for Neuronexus and Neuralink, it made up for a PhD, I would say. But at the same time, it's it I get to work on one focus thing. I acquired a lot of skills that work for this industry, but I can never tell people that I'm a doctorate, right, in this one particular project. Some people work with graphene, some people work with silicon carbide. They can claim that they know everything about it. And I'm sure, because you're 5 years day in and day out when you're studying this, you're bound to know a lot about that thing. So it really comes to personal preference, whether you want to dive into something that will pay off, or you want to just pay your dues as a young employee, as a young grad, and then work your way up in industry. I think regardless of where you go, you're still going to learn. So you're not there's no wrong decision, I would say. To be in neurotech, I think before 2015, I would say investment was little. There wasn't a lot of money in this field. It was a I don't know. I mean, the only word that comes to mind is audacious. It was an audacious thought that here we are, and when you put something in the brain and you're controlling a living being, you're playing God, right? And a lot of people didn't want that. And they thought this is ludicrous. I don't think this is going to be a reality. But to 2015, and now the billionaires, like Elon, Peter Thiel, they started believing in this. Facebook invested in this. Amazon's doing something on this. It's Google, really, life sciences are doing something on this. So that investment suddenly drew a lot of people in. And that's when, now the same companies that were hiring, or the same entrepreneurs that were working on this, they didn't need a PhD to get in. Like, they didn't have to be the best in the field to get in. Now there were a lot more jobs, there were a lot more opportunities. And again, when you're working in a company, you're doing everything, right? It's a ship. Everyone's, rowing their way, moving the ship forward. So as long as you're good at one thing and are able to, help and deliver in other aspects of the company too, you're wanted. Era, I would say, of course, a PhD always helps. Like, that education is never going to waste. But that era of needing to be super specialized in neurotech is now gone. You can, even with skills, with your basic undergrad skills, you can contribute a lot to the field. So just to summarize, evaluate the PhD topic, know what the payoff is and what the opportunity cost is. Because 6 years is a long time. You're living on students' pays, and at the same time, like, you see your friends earning lakhs of rupees, hundreds of thousands of dollars, and it's going to be good. It's going to be challenging. So know the value of that thesis. Only if that thesis payout is going to be, the delta is going to be large, it's only then would I advise you to get in.
So, like, that was amazing advice. I think most people have this question or worry. So while we are at this topic, what do you think is the biggest misconception that students and enthusiasts have about this field and this industry, and how would you debunk them?
I think a lot of people misjudge how much work there needs to go into this field before it becomes something.
Right.
A lot of, like, people who've attended talks, or who learn about what I've done, what I'm doing, they come to me and it's like, isn't this bad? Like, isn't this, like, won't AI destroy us, or won't someone have brains? And it's impossible. Like, it's like telling someone, can you hack a mixer, or can you hack a microwave? Yeah, sure, you can screw it up, but you're not hacking a living being. You're not controlling, like, every thought of theirs. There are 85 billion neurons in the brain. You've got 1,000 channel device inside. How to control anything? How's AI going to control anything? And people often mistake to dumb it down, our body is electrical in nature. The brain works with electricity, but you're missing out on the biology of things. We're living beings, right? It's only after years of evolution that we've come to this stage. So a big misconception that a lot of people have is, this could be bad technology, right? This AI could take over. No, it's not going to take over. Don't worry about it. And there is a long way to go before we get to that stage. Right now, we're at a stage where we can diagnose certain things, right? Like we can work with the motor cortex, or we can work with the hippocampus. The brain is large.
Yes.
If you access everything, you have to come up with innovative solutions and new thoughts. So I would say that's probably the misconception. The other misconception is that there is no future in this field, or there is no money in this field, and I would say that's incorrect, because the moment you have a medical device, there's a huge payout because the people waiting in line to use this,
Yes.
and people need it. It's not stemmed out of a concocted thought or application. You don't want people to get healthy people to get this. Sure, they can if they want to boost their externalities, but for people often mistake the fact that there are actual patients waiting for this technology. So there is a payout. Like once you have a successful device, there is a payout to this. So there is money, plenty of like investment going into this. There's a lot of excitement. AI is not taking over. So two big misconceptions there. And I would say the third one is that a lot of people tend to think of club neurotech into one thing, like as if it's geography or history. It's not. It's an amalgamation of several fields. You need to know biology. You need to know electrical circuits, basics of electrical circuits. You need to know material science. You need to know a lot of things, right? Physics, chemistry, and it's only then that you're really like, so getting to that stage or just one course in this is not sufficient. Um, you have to work quite a bit and understand a little bit about everything in order to really contribute to the field.
Yes.
People come to me and say like, "Hey, I'm good at AI and I've done so many assignments. And do you think I work at your company?" Like, it's. I don't think it works that way. Because you're recording electrical signals, right? Like you need to know what you're doing. It's not a software. It's you're actually interfacing computers with biology, with human beings. Those three are probably the biggest misconceptions, and that's from a viewer's standpoint. From someone who's in the field, I think some misconceptions are that is this when do you is there a solution for it? Like a lot of people ask me that, is what you're making the final solution to figuring what we need? And it's not. And so flexibility and being able to adapt, or being able to realize that you could be wrong, is a virtue that I would say needs to be inculcated in a lot of people who are in this field, because they need to know that don't stick to a dogma, right? Don't believe that
Yes.
because you've done this, this is destined to work. If it did, it would already be in use by now. I mean, there's a lot of people doing this. So I think like understand that, be ready to fail. I would say, or be ready to pivot, and don't have dogmas in this field. Like just because basics of EEG doesn't mean you're going to be good at intracortical, or vice versa. Just giving an example. Know that there are different answers to this problem,
Yes.
different ways to go to, and you got to understand most of them, or try to understand most of them. Don't go in thinking this is it, this is the be all and end all. So be ready to pivot. That's, I would say, the most crucial advice.
Yes, I completely agree. I mean, ever since I have been in this field, the other day I was just reading this paper and then I realized, oh wait, I need to know what this neuro inhibitor is doing, and what is this transmitter doing, what is this chemical, how is this chemical reaction happening, and I did not know any of it, but I had to learn all that just to understand that paper. I mean, even I feel that it is very important to be multidisciplinary and be surrounded by such people to succeed in this field. I mean, this is not a field that can be specific to a core subject or core field. which is exciting and scary. I mean, it is very exciting because I get to meet so many different people from working in so many different domains. I like you think of it and there's someone working in that field in neurotech. I mean, it's very
True.
exciting. Like that is an excellent note to end this the whole discussion. Finally, the last question I think everyone wants to know is. How do you envision the next 5 years of this industry? Where do you think is this
Oh,
industry heading towards?
I think so far, like the past 20 years, up until 2015, I would say things were linear. Things
Mm-hmm.
were slowly, it was picking up interest slowly. I'm just going to give you a little anecdote because I think it's important. The invention of this, right, technology, the invasive neurotech, was done in the 70s. I mean, people did this much before, but really, like the primitive version of what we do was seen in the 70s. But no one took it up. No one did this till the 90s, and it's only after the 90s that they said, oh, this works well. And then slowly, the people got convinced. Slowly, people, there was early adopters. 2015, big time, because President Obama also initiated the brain initiative. So a lot of grants given out to study the brain. And just like the Human Genome Project,
Mm-hmm.
which began in the 90s and ended in 2010 or something,
Mm-hmm. Yes.
there's a new thing called the Human Connectome
Connectome.
Project,
Yes.
where everyone across the world is trying to understand how the brain works.
Mm-hmm.
And suddenly, like after 2015, the rate has been exponential. It hasn't been linear. It is just shot. So the number of neurons that, again, like I'm talking from a very basic level, the number of neurons and the information we have today has just like exponentially increased in the last 5 years. And this rate is going to continue. They draw an parallels between Moore's law in the electronics in the
Mm-hmm.
semiconductor industry. The Moore's law is that you're
Mm-hmm.
able to fit twice as many devices in the same area. Like the technology shrinks, and just similar to that with the brain, every year that goes through, you're understanding every generation, you're understanding twice as many neurons that go through. So the rate has been exponential, and just like in the last 2 years, I've seen so many devices get pre-market FDA approvals. It's phenomenal. Like
Mm-hmm.
if there is a time to be in this market, this field, it is now. Uh, and I see this field in the next 5 years. It's going to draw a lot of investment. It's going to see a lot of good research, and regardless of whether this succeeds or fails, we're still going to understand a lot about the human brain that we didn't already know. And that's what the exciting period is. So how the 5 years going to be? I think we're going to know a lot more science. We're going to get a lot more investment into this field to study the science. And at the end of the day, like, maybe 5 years, 10 years down the line, if there is a cure, if there is a treatment for Parkinson's, which there already is, like stimulation is already one of the therapies. But if we come up with a conclusive treatment, right, for Parkinson's or Alzheimer's,
Mm-hmm.
now to everyone towards the end of their life does face some sort of dementia
Yes.
or neurological
Mm-hmm.
damage. And at that stage, if you can help, implant, if you can like improve your quality of life, pacemakers, same technology, like it's everyone uses it now, right? Cardiac patients use it. So the same technology with the brain, that's what I see in the next 10 years. All of these problems, right, like with anxiety or clinical depression, Parkinson's, Tourette's, essential tremor, they're going to find solutions, and there'll be ready solutions that will be adopted by people. And honestly, it's my hope that by the time I get to 60 or I get to 70, where my neurological condition is slowly deteriorating, I hope this becomes a reality. And I see the golden era of that research, of that technology happening in the next 10 years. So exciting times. I think so much to learn, and it's like really in modern evolution, I would say. I think this is going to play a big role in that, being an actual android, like not just limiting it to a smartphone, but being an
Mm-hmm.
android yourself.
That is such a nice note to end on. Thank you so much for talking to us and sharing your experiences. I think more than anything, this field needs people who share their experiences because there is a lot of resources out there. There's an inundation of resources, but what's lacking is journeys and experiences, guidances, and role models. And I think you are a perfect role model in terms of so much that you have achieved in such a short.
Thanks for having me as your first guest. I hope our talk, my experiences have given you some answers that you were looking for, and just like excited to see what the next generation of bright neurotech enthusiasts bring to the field.